thank you all for joining us today. And just to give you like an idea of how this afternoon is going to run, is this first session, which is going to start out with some basic concepts about best practices in data management, and I'll tell you how that will go. Will then lead into a talk by a member of our team, Ying Zhang, who will be talking specifically about how NSRR tries to further enhance best practices and what we try to do once data gets into a data repository. But really, a lot of the principles that she'll talk about really reflect some of the ones that I will be introducing in the first talk. And then after Ying's talk, Shaun Purcell then is going to really dig deep into some of the issues about handling specifically physiologic or sleep-related signal data. So I think you're going to get a wide spectrum of information, and we'll start fairly general right now, and then we'll go as the afternoon goes in, it will get deeper and deeper. And even in this talk, the way it's going to work is I'm going to introduce some of the motivations and some of the general approaches for best practices in data management. Then Meg Tully, who recently joined our team as a research data manager and actually works with the NSRR data as it comes in, as well as other projects, will give you really an on-the-ground feel of what are some tips and approaches to really making those best practices sort of come to life. And then we'll conclude with Michael Rueschman, who some of you know because he does a lot of our support for NSRR, and he's going to give some good examples that will, I think, drive home the points that we spoke about. So to begin with our motivations, so data management is actually requires a lot of work, and it's often not glorious. But despite not being glorious and a lot of fame and so forth, it really is critical for two main reasons. One is it's really the foundation of good quality science. And by following good data management, we could work at making sure that our research meets the overall scientific imperatives for rigor, reproducibility, and transparency. And if those words sound familiar, it's because those are criteria that your NIH grants are judged by. And the second is that by having good data management itself, it will enhance the understanding really of your analyses and the interpretation, and really allow you to really match your hypotheses with the outcome, as well as understand the limitations. But the second major impetus for good data management is that it enhances, so to speak, the return on the investment, meaning by following good data management practices, one is able to more efficiently kind of do your analyses, meet your own goals, as well as share data with others or pursue secondary hypotheses, thus really expanding the the power of the data that you spend so much time collecting. And by doing so, you're creating a resource. Good data management allows a resource to be developed, and thus can reduce the cost of doing studies or collecting new data all over again. And in fact, the NIH has identified really that the scientific community basically has to step up its game in terms of how data management is done, the formality, as well as promoting sharing of data in well-defined repositories. So we mentioned this in our last webinar. In our next webinar, we'll go into much more details on the newest NIH policy on data management and sharing. But I just want to emphasize that, we all will be required to follow many of the practices generally that we'll touch on today, including creating well-documented metadata and defining the standards for the data that we collect and the procedures we use. I will also note that NIH, has made it very clear that approval of future grants may be contingent on having, these data management plans. And I would imagine over time, they will also be evaluating the quality of those data management plans. The other area that NIH and other federal agencies have really been promoting as far as data management was, again, fear and trust principles. And we'll go into, these, in later webinars, but just to recognize that data management is also supposed to support the goals of making sure that your data is findable by others, that it's clearly, explicitly identified, it's accessible, retrievable, it could be interoperable with other data sets and reusable. And much of that depends on really, these best practices, which include clear, unambiguous definitions, the use of well documentation, including metadata. And then the trust principles, which is the other side, describe criteria for repositories. And we will get into that more in the next webinar. But to begin getting back to data management and best practices, I wanted to outline really kind of a tiered approach. And like everything, when one is doing something that can be challenging, you need to plan it out. And in fact, really good data management is usually linked to a well-developed data management plan. And in fact, you often will do that, and you should do that before you start collecting the data. And it should be done generally with input from other experts as well as stakeholders. And by stakeholders, I mean those analysts, students, et cetera, who will be using the data. And potentially, if you do policy work or epidemiologic work, possibly even those individuals who want are dependent on the results of your research. Secondly, like any operationalization of anything, you need to have the right people who are qualified to carry out these responsibilities and really make it very clear who's responsible for what, because there's really a number of different tasks associated with data management. As I mentioned, FAIR principles are important, but also we know that there are also a number of tools, electronic tools and other tools that may make data management possible. So specifying sort of really kind of how you're going to leverage the standards, tools, and even automation all may enhance your data management plan. And like anything else, once you implement and do something, you have to continually check yourself. Are you getting, is your data management, your ingestion, your definitions, your output procedures getting you the results that you expect? So quality control. And in fact, this notion of having a number of steps, I think, was very well articulated by the EPA. Actually, the EPA collects, that's the Environmental Protection Agency, gets a lot of data from very diverse sources. They do all this geological, environmental, multi-source data, and they have a very big stakeholder group, all of us. So they really have very nicely published a document that really describes what they refer to as the life cycle of data management, which again starts with planning, that data management plan, the actual acquisition plan, the process of manipulating, deriving variables and analyzing them, and then storing them, and then sharing that knowledge. And across that whole process, there's a number of cross disciplinary types of activities that are functionalities that require the whole team to work together to ensure that the data are described and documented in sufficient detail so you can understand the validity and the source of the data, and that there are data quality assurances really in the beginning and that continue through the end of the project, and that the data are well documented, and there's a plan for backup and security. So now very quickly, I'm going to just give you a few high level pointers and then turn this over to Meg. So again, thinking about that life cycle, first is that process of planning data collection. As I said, what will you collect? Who will collect it? Who will be responsible for, each of those activities in the life cycle? Who will use the data? Who's your stakeholders? And who will be restricted from using it? And what are the procedures you'll use to optimize quality and reliability? As I mentioned, the NIH data management plan is also, wants you very early on to define the types of data that you'll collect. And Meg will give you some good examples of that, as well as what standards will apply for your data, the way you label your data, the way you describe them, the way you use metadata, the way you organize your data dictionaries. And then during the whole process of acquiring data, there's a lot of thought that has to be given, depending what your scientific question is, on the resolution of the data to meet your hypotheses. Do you have to collect data on, at a very granular level or a global level? And how often will you collect data? What will be the sources of the data? Self-report, objective, daily measurements, area level measurements. What are the, what do you need to include in your metadata, which will, again, data that describe your data, and, make sure you understand elements such as the source of the data, any computational derivations, any restrictions to the data, and so forth. What formats that you will use, and generally you'll use open source when possible, how you'll identify your samples of individual records, whether you'll use a data model. That's a model that describes how the different data elements relate to each other, how your workflow will be generated, like as you collect data, what happens when, at what point do you ingest data at a certain level and then check for outliers and then summarize at different levels and so forth, and where the data is stored and archived, and then the quality control across the whole procedures. And the data, and then in the sleep area, we're particularly interested in defining how we process data. We can get data from questionnaires, blood, ectographs, sleep study, polysomnography, and more. And many of these sources of data really are ultimately going to have to be integrated. We'll have to extract data at different levels, sometimes apply calibration, sometimes transformations, and then other standardizations. And I think between Meg and Mike and Shaun, you'll see some examples of that. So that's my very brief overview. And now I'm going to turn it over to Meg to go one deeper level and hear from someone who's really on the front lines of how she approaches some of these issues.
Yes, thank you, Susan. So when we're talking about best practice for data organization, data management, and quality control, it would be fantastic if we could say that there was one best practice, one standard, and one way to do it that's right. But really, it always has to be customized to the scale, the scope, and the specific aims of the study that we're talking about. Despite that, though, there's some key kind of approaches and principles that can underline all good data management plans. So a really important one is being consistent and having clear documentation. So the documentation is that step in the EPA diagram that underlined all the different parts of data management. So documentation at every stage and at every level. Another one is thoroughly considering how reliable the methods that you're using are. So trying everything we can to avoid too much human interaction, anything by hand, because we all know that no matter how careful you are, as we scale up the size of data sets, anything that's being entered manually has a really high chance of getting mistakes and errors and typos and things. So it's also important to consider thorough record keeping of all these different steps. So how are we doing things? How's that changed? If things are updated throughout the course of the data management plan, what has changed? Why has it? And just keeping that all on record. And this is all a part of having a proactive and preemptive approach. So looking forward, thinking about the endpoint, thinking about the sharing and where the data is going to end up instead of just kind of the immediate short-term goals. And another really important part is having some standardized and relatively thorough ingestion or like data acquisition checks, so that when the data arrive, when they're fresh and the people that collected them are still kind of in contact, it's really important to do those basic logic checks and see how the data are going and the management and the quality, instead of kind of waiting till much further down the line. And it can be harder to clarify and address issues when the people that collected the data or the clinicians involved are no longer around. Next one, thanks, Susan. Oh, yeah. So when we're thinking kind of at a high level about how to do data management, we are really highlighting documentation at the moment, because that's the way that we can make the data more useful. So a good way to think about it is, if the study team or if you yourself weren't around in like a long time, maybe 10 years, would someone who picks up this data be able to use it? Would it be meaningful? Would it be understandable? And that can be different for different studies, but it's going to include how the data is collected, what are the relevant instruments, and what's happened to it since then. So by doing this and by doing it thoroughly, the data can really stand on its own. It can be more useful, it can reach more people, and it can have a greater impact. So it really can benefit all of us. Just next, thanks. So more specifically, when we're talking about how to be thorough and careful and proactive with our data management, a lot of these things need to happen as early as possible, ideally before any data is collected. So we can record and we can decide with like the relevant stakeholders, what kind of data are we collecting and what will it look like? So commonly we're talking about sort of spreadsheet data, entries in variables. So what will each of those variables be? Is it a date? Is it a string? Can it be any like free text? And if it's a number, does it have to be a whole number? Does it have to be positive? What are the allowable ranges? What are the logical ranges? If it's a category, if you're picking, different options, which is very common, what are the allowable options? Can it be missed? Some software have ways of ensuring that it's not possible to pick nothing, or it's not possible to pick two options. What are we going to do in those cases? So lots of things to think about, and ideally to think about them as early as possible, and to think of an approach that is clear, as simple as it can be, and that you'll be able to explain to other people down the line. Next, thank you. So more specifically as well, it's really good to think carefully about the kind of files, the kind of naming, and how they're going to be stored. So like Susan said, open source is what we're kind of hoping for here. That's the best standard, something like a CSV, or for polysomnography data, often an EDF. And yeah, how will they be named? We've all had that experience of receiving, final dataset _ final version 6, so it can be something as simple as labeling our versions by the date, organizing them in logical folders. And we have lots of different files relating to different kinds of analyses or different instruments to think logically about how you arrange them. There's not one way to do it, but you just need to do it with some intention, I think is the goal there. Next, thank you. So this is just an example. I mean, as Susan said, there's lots and lots of different types of sleep data that we come across at the NSRR. So there's lots of different things to think about. And this table has some of the examples of areas that could be considered before collecting your data. What's the size we're thinking about? How aggregated will these be? Is it at an individual level? Do you have multiple records for one individual? What could be the relevant consents and restrictions? What kind of privacy concerns need to be considered? And how does that vary across different aspects of some of these large studies, which have lots of different dimensions and lots of different areas? Next, thank you. All right, and another really important thing that we think about a lot at the NSRR is de-identification. So when you're creating your data set, when you're thinking about your data management plan, where is the sensitive data being stored? How is it being stored? And when you're getting up to a shareable version of the data set, doing those thorough and ideally straightforward checks for all the different kind of PHIs. And, this just needs to be done with a bit of thought as well. We've talked a little bit about like dates. If you want to include dates, they can be shifted randomly. Things like zip codes at a large population level can be considered not like private information, but if you're talking about a zip code with a smaller population, that can have a different level of privacy. And the other one can sometimes be like niche diagnoses of rare conditions. So it's thinking thoroughly about what are all the different ways that this could be traced back to our participant. And again, just doing it all with some intention and some pre-thought. Thank you. Alrighty, and then where this, like a lot of these principles come together in a really practical way is creating a thorough and useful data dictionary. So ideally, you need your data dictionary, if we're talking again about spreadsheet data, which is what I mostly been dealing with, you want to have a one-to-one match that every single column in your data set has a row in the data dictionary. And that row can explain lots of things. It should have the name, it should have the meaning. We would like ideally to have the units, what kind of data it is, how it was collected, are there any issues, how has the missingness been evaluated, what are the relationships between variables, and anything else that's useful to help understand the data set. We see often that some quite well formed data dictionaries early on can hit a little bit of a struggle when it comes to derived variables. So maybe variables that have been calculated to summarize different forms or to summarize other values, they're often sort of left off. So it's keeping that data dictionary as thorough as possible to explain every single variable and have all the relevant information so it'll be useful down the track. And again, keeping copies of that. So like at the NSRR, we use Git to kind of version control so that it's all on record and you can see where things have changed. And if you make any changes to the data set, you know exactly what's happened and it can all be traced back if need be. I think that's all of mine. Lovely. I'll introduce the lovely Mike Rueschman then.
Thank you, Meg. Thank you, Susan. So to round this presentation out, the three of us, brainstormed some ideas and contemplated what we do at the NSRR and what a generic data sharing repository may do with your data down the line. I think we have a more hands-on approach. We've taken many pointers from BioLink, another NHBI repository, in terms of what we do when we get a new data set deposited with us, and we thoroughly review all the metadata and data that have been given to us, and then we have an iterative process going back and forth with the data owners, clarifying things where we see incongruencies between, perhaps like Meg is describing, a spreadsheet of data versus the data dictionary, where columns in the data set may not be described in the data dictionary or are not sufficiently described with unclear labels or ambiguous meanings. And we go back and forth, we send our findings back to the data submitter, ask them to respond, either add new variables, remove redundant variables, so on and so forth. Next slide. And so we had a list here to bring us home of preempting issues, and all of this is about being proactive and thinking about those users down the line. And this is an example, or all these examples are from things we've encountered at the NSRR. Confusing variable meanings or ambiguous meanings. And the example we've given is for those who work in sleep, a common concept would be REM latency, or one definition could be the interval until the first REM period, whereas more specificity may bring it and make it clearer, do something like the interval between sleep onset and the first sleep epoch of REM sleep, including wake. So the including wake portion or excluding wake epochs has been something we've encountered and needed to clarify with the data submitter before. So as you're building out your data dictionary or making sure that we use the clearest definitions as possible, as well as any calculations or what components go into building another derived concept in your data dictionary and data set. Next slide. And Meg mentioned this, it's important. Sometime one thing we've had to iterate with data submitters before is making sure all the values that are present in the data set are covered, and namely missing codes often go not fully documented. And it's our preference, or in our suggestion, and what we are trying to do in our own work, is to be consistent in the missing categories we used, either one of these sort of patterns like NA or system missing consistently throughout. And if a user potentially is not paying attention and tries to just use values out of the box without excluding these missing, well-documented missing options, they may come up with implausible or impossible ranges like -3 to 14 average nights. And it can be useful at some point to distinguish things like not asked versus not answered or prefer not to answer. And so this is something to always keep in mind in your data collection system, how it, one, handles missing codes on its own, and how it outputs them, and then how you are defining them in your final data set and data dictionary. Next slide. And no one is immune from data entry mistakes. And just if you try to keep this in mind, that EPA slide that Susan showed about doing quality checks and reviewing your data from day one all the way until the time that you're trying to preserve your data for data sharing. One, you probably, most people's data entry systems or data capture systems have mechanisms to try to catch out of range or illogical values. So implement those as much as you can from the get-go. Working with sleep data a lot, a common thing is we collect sleep diaries, and we have 12 mixtures of 12 and 24-hour clocks. And so again, try to use your data capture system to overcome these, and as well build out QC checks that you can run in post-processing to capture them and hopefully go back and reconcile them before you get to the end of your study, such that your data set is nice and ready to share. And I think I was particularly thinking on this point about skip patterns. Sometimes you can also have a special missing code for those, such that one data dictionary we processed used a code of S for meaning skip rule followed. And that allows us to distinguish sort of expected missingness or missingness due to being skipped and not even asked to the participant versus other types of missingness. So next slide. And we've talked mostly about sort of phenotype, covariate, spreadsheet type data, questionnaires, results, other things, but also considering all your other data streams, like physiological signal data. We work a lot with polysomnography, actigraphy, so on and so forth, or any other types of device data that you're also fully documenting all the processing steps that you're taking with those from the get-go in terms of exporting, in terms of, obviously for EDFs and polysomnography filtering is an important issue we often come across, as well as sometimes the EDF export fails and we get truncated files or corrupted signal files. So having QC mechanisms to check those along the way, look at file sizes, run them through an EDF checker to make sure the EDF is intact and following the file specification that we want or is necessary to analyze the data down the line. And also, if there are ways that you can compare different data sources to one another, that you're checking your physiological signal data, for instance, let's say the total amount of sleep stages represented in your polysomnography annotation files against your phenotype covariate data set, where you have those derived metrics already imported from another data source potentially. If you can cross-reference those sources against one another, that can be really helpful to catch mistakes or exporting problems, truncation problems, and ideally revise and correct any electronic data before you get to the sharing portion. Next slide. And another pointer going along all this metadata type checking with ambiguous units, making sure your data capture system has this well defined, such that potentially users across multiple sites aren't entering data in different units, and also your range checks should catch this sort of thing. And try to pre-specify and delineate on your data collection forms from the very beginning what those units are going to be, and also include them in the data dictionary that you're going to share down the line. Next slide. And oftentimes for summary scales or standardized instruments, it's, I think, doubly important in your documentation and in the data dictionary when you have a derived result, potentially one that was comprised of a number of component variables, some of which may need to be reverse coded, others may not, that you, one, both include the citation to the original instrument and its history and the scoring rules, as well as document the exact process that was taken on your source data in the description of where your derived variables are, to plainly explain where reverse coding is used and on what variables and why, and cite the source. Next slide. All right, so that'll wrap up our portion on data management, and I think I'll open it up to questions and take it back to the presenters or hosts. Thanks.
All right, if there are any questions for the presenters, please post them in the Q&A. We have a few minutes available for that. Okay, well, we'll have a general period at the end for any specific questions that you'd like to ask. So post it in the Q&A and we'll have some time then. All right, for our next speaker, I'm very happy to present Dr. Ying Zhang, who is a data scientist at the NSRR, and she's leading the NSRR's efforts at data harmonization and for establishing metadata standards. And so she will talk about how she's been able to, take some of those concepts and bring them to the NSRR. And okay, let us turn it over to Amy. Hold on 1 second.
Thank you, Mike.
Okay, here we go. And this will be recorded. We'll have to see about making slides available afterwards. But all of this will be recorded, and all of these talks should be available as a video on the NSRR website. Thanks.
Mike, can you see my full screen slides?
Yep, you're all set.
Okay, great. So thank you everyone for attending our second webinar series. And then I am Ying Zhang. I'm happy to talk about once we receive data from our data owner, what do we do to improve the data and metadata quality and how that can help our users, especially if they want to do a multi-datasets analysis. So I will first start talking about why you might consider doing multi-dataset analysis and the challenges in doing so, the difference between data standardization versus harmonization, the kind of data and metadata curation we do at NSRR, and examples of how that curated metadata can help our users and owners. So why do you want to work with multiple data for your research projects? Single data, single cohort is clearly cleaner, easier to work with. It's designed to maximize population and technical homogeneity. However, it might be subject to overfitting. You can do internal validation by partitioning your data into testing and training data set and do holdouts or cross-validation. However, sometimes it could still be hard to generalize your findings. Working with multiple cohorts and data set, on the other hand, you can increase the sample size and the statistical power by doing like pooled analysis or meta-analysis. And you can also do external validation. I think there's an increasing interest in publishing papers using external validation data set. So by leveraging the heterogeneous study population, you can really improve the generalizability of your study findings. So that all sounds good. Then what makes cross data set analysis difficult? When we work with data sets, we come across a variety of inconsistencies. So here are 4 main categories. So keep in mind those inconsistencies are important if you want to do multi-data set analysis, but also relevant if you want to work on only one data set as well. So the first kind, I would call it semantic inconsistency. So some sleep domain terms, they are commonly used and people all know what they mean, like total sleep time. But other more generic terms are not used consistently. So one example is this sleep duration. In one study, it might mean the interval between sleep onset and offset, including WASO, and then excluding WASO in a different study. And those descriptions are not necessarily included in the data dictionary, so users might not be aware of that difference. And then even for terms that are semantically the same, for example, apnea-hypopnea index, it sounds pretty straightforward and should mean the same thing in all data sets. However, depending on how the respiratory events were scored, it can still differ a lot, especially when you compare older studies collected in maybe early 2000 versus most recent studies, because the ASM guidelines for scoring apnea and hypopnea events have changed over time. As we mapped out here, there are 4 versions or 4 iterations, and 3 of them have 2 versions, the recommended and alternative. Even for a sleep expert, a clinician, it's extremely complicated and confusing. An average user might not even be aware of this difference and end up comparing apples to oranges. So that's the technical inconsistency. And then another kind is called measurement inconsistency. So we see that a lot in sleep questionnaires. So even when you measure the same concept, here example is daytime sleepiness. In some data set, they might ask, how often do you feel sleepy during the day, which is a frequency type of measurement, versus how sleepy do you feel during the day, which is a severity kind of measurement. And it's not very clear for an average user how these two can be compared and how to use them together in their analysis. And then the 4th kind is what I call unknown inconsistency. It basically means the kind of inconsistency getting introduced during the process of data collection and processing the average user might not be aware of. A good example is this a variable called staging 5. Basically, it's a signal quality flag. So I try to explain it here in a simplified way. So polysomnography data has many channels of signals. Sometimes the EEG signals are not good enough for sleep staging, but other signals are still good. So in that case, some studies will use a very complicated method to generate a staging quality flag to identify observations that can only distinguish sleep versus wake, which will be marked as stage 2 in the data. So no REM, no arousal scored for those observations. So if you do multi-dataset analysis, it's important if when you combine, study that has full staging versus those do not. Okay, so before I jump into trying to explain what we do to address those inconsistencies, I want to talk about the difference between standardization and harmonization. Because at NSRR, we receive data that's already been collected, so everything we do here is retrospective. So retrospective standardization is basically the process of metadata curation to address some of those inconsistencies, especially semantic and technical, while harmonization, and also by standardizing the data format and metadata, we can greatly increase efficiency and minimize chances of introducing unnecessary errors in your analysis. Harmonization, on the other hand, is meant to improve comparability of similar measures representing the same latent construct in different data sets. So that would require some subject matter knowledge or domain expertise to assess the heterogeneity and make decisions to generate inferentially equivalent, aka harmonized content across data sets. So here's a list of the kind of standardization and harmonization we do at NSRR. So we start with a kind of simpler one. So here is data organization. So if you've been using NSRR website, our data dictionary is organized in this folders, subfolders, tree structure. Before, we sort of use the data owner's default way of organizing variables, and it can vary quite greatly from study to study. So if you want to browse and look for, lab test or clinical exam variables, you'll have to click through all those folders and subfolders to find all those variables. So we try to standardize the folder structure so that we improve the browsing experience for our users. So for now, if you want to look for seated blood pressure, it will always be under clinical data / vital signs / seated blood pressure, for example. but we also try to keep the provenance information, meaning like all the where that variable is from which form, which visit, those information are still kept in the variable level metadata. And then for the standardized terminology, as I mentioned before, some sleep terms are not used consistently in data sets. So we develop a set of standardized sleep architecture terminology. So terms like period or duration now have specific meanings, and we use them consistently. And then another example will be the PSG channel labels, which I think Dr. Purcell will maybe cover that in his talk. And then we also look at our variable labeling. So for example, the AHI variable, we can really improve that by incorporating some important study level metadata, which I will show in a later example. And then for some validated instrument, as Mike said, it would be useful if you include references, maybe scoring rules and how to interpret the scores. Well, those are all very useful to our users. And we also develop tags using compositional coding scheme, which itself will probably be some blog post we will release later to explain what they are. But basically, those tags are developed to help our users to find data they're interested much easier. I will show you in the later example as well. And the last but not least is the harmonized variables. We actually developed or derived inferentially equivalent data for a small subset, including non-sleep covariates and some polysomnography variables across NSRR data sets. So now I'm gonna go into the actual examples. How NSRR metadata curation can help our users. I'm going to talk about the harmonized demographic and polysomnography data, and also the validated survey instruments. So the first example is this gender variable. If you pick any 4 data sets on NSRR website, it's likely that you will see this sort of variation in the variable name, the coding for male and female, the missing code. So if you want to combine them, it would require some cleaning to make them really equivalent to one another. So as part of the NSRR harmonization effort, we identified a subset of those non-sleep covariates, including sex, and then we harmonized them to the TopMed and Biodata Catalyst standards. So the new harmonized term now, it has this prefix NSRR underscore and then sex. And instead of using coded value, we actually use string, which is promoted by TopMed Harmonized Phenotype Data project. So we just have male, female, not reported in the data set. They're all in lowercase, so it's great for our users. And if you search for NSRR underscore sex, you can see those are the hyperlinks to the TopMed and BDC standards. And also you can find the source variable from the data set. And it's currently available in 16 data sets. So as for the signal quality, as I mentioned in the unknown inconsistency, we think things like this are very important. And then we want to sort of highlight this sort of signal quality inconsistency by including this particular flag variable in our first batch of harmonized polysomnography data. So now if you search for NSRR flag SPSW, it will show you we have 7 data sets that actually have that flag developed, and then a detailed description of what this flag means, how to use it, are all in the labels. So we've done that the harmonization for 9 core non-sleep covariates, including age, sex, race, ethnicity, BMI, smoking, and also seated blood pressure. We also have harmonized some core PSG variables focusing on AHI because that's a very popular variable among our users. So there is, we're trying to write up some blog posts explaining what those variables are and how to use them. So stay tuned. And by the way, we're going to expand this list to other PSG variables and potentially actigraphy variables as well. And here's an example of improved metadata for validated survey instrument. So the original variable metadata, as you can see on the left, is basically just simple descriptions, a total score for Women's Health Initiative Insomnia Rating Scale. So what we did, we added the basic kind of scoring rules. There are 5 items, and how this summary score is generated, the range of the score, and how to interpret the score. The higher means more severe insomnia. And then we also have this reference to the original paper. And then if you click on this, search for all WHIRS variable within the study, it will pull all the items from that scale. And then in this tag column, if you click on those 2 tags, it will actually launch a NSRR wide search for the validated instrument and its component in all data sets as well. So that's for how we can help data users. In terms of how we can help the data owners, there's an example of the metadata improvement we've been doing with our data. So one example is the polysomnography summary data. The original metadata management system the data owner might be using is just a simple study manual plus a very minimum kind of data dictionary on codebook. The variable name is AHI. The variable label is apnea-hypopnea index. So that could be improved because, you know, as I mentioned before, like there are other technical inconsistencies that can potentially be associated with this variable. So what we did, first of all, we kind of developed many other metadata for the study. So in addition to the study level, the study manual, we also developed the structured study level metadata using the metadata intake form. We have developed the simplified README file, which is published on the NSRR website. We also add the study to our cohort matrix, which I'll show in the screenshot later. And then we improve the variable level metadata. So here is a screenshot for our cohort matrix. If you haven't used it, I strongly encourage you check it out. The URL is matrix.sleepdata.org. So there are multiple tags in this app. The first tab is just an overview of the data set. The second tab, you can see the data availability by category. So if you're interested in, say, incident outcome of the data set, you can find, you know, certain data set will have that. So it could be very useful if you're trying to identify data set to meet your research needs. And then here's an example of the kind of metadata standardization we do. The original variable metadata is very simple. It's minimum apnea-hypopnea index. And then after our revision, so first of all, we include how the apneas and hypopneas events were scored. So we have, you know, how much flow reduction or the percentage oxygen saturation threshold and whether or not arousal is accounted. And then we also pulled information from the study manual regarding what type of polysomnography test is a type 1, 2, or 3. And then in the description, we also try to map that AHI to the closest AASM guideline. And then we include the reference to that guideline version. And then again, you can do a search for all AHI variables using that definition for respiratory events. And then we also have those tags now you can use. So for example, this ASM 15 underscore acceptable, if you click on that, it will do a search across data set, pulling all AHIs that's consistent with ASM 2015 acceptable. Okay, so I think I will just pause here and see if there are any questions.
I don't think we have any current questions, so we'll save them in case people are saving them for the end. So thank you so much for your talk. This was really interesting, and I hope a lot of people will be able to think about this when they start moving forward. So thank you. Okay, so our final speaker for today is Dr. Shaun Purcell. He is an associate professor in psychiatry at Brigham and Women's Hospital and a co-PI on the NSRR. So Shaun, whenever you're ready.
Hi, thanks, Mike. Can you hear me?
Yep.
Excellent. And second question, can you see my slides?
Yes, we can see everything.
Perfect. So thanks. So as noted, I co-direct the NSRR along with Dr. Redline, and it's my pleasure to speak today about some of the work we're doing with the signal data, the PSG data, primarily aimed at making it more readily usable by others. So I'll start with, I think, some of the opportunities rather than the obstacles. This is just one example. It's a study that actually doesn't use NSRR data we came across in a lab journal club a year or so ago. And it describes a particular EEG marker, that the details aren't important in this context, but that it tracks with levels of arousal. And relevant here, it varies between REM, non-REM, and wake. And so it was a nice paper. There are a number of components, but one of the core one was looking at sleep PSG and making this kind of point. But in large part, perhaps because it involved other data types, imaging data, and so on, the sample sizes were small. So N of 14 here. So where does NSRR come in? So literally within a couple of days of reading this paper, we were able, using the open NSRR data, to basically replicate this in hundreds, thousands of individuals, and ultimately in 15,000 different studies because of this open NSRR data. I should say, obviously tremendous efforts from Natalia Kazemiako and my group, and we leveraged some software we had spent time developing, but relevant here, in many ways, it's the NSRR data that kind of made this kind of very quick, large-scale replication of an interesting study kind of possible, and this now has just been recently published. And to my mind, this was one example, and obviously there are many others from other investigators elsewhere. In my own work, I've leveraged NSRR studies in various contexts as well. This to me seems to exemplify exactly one of the motivations for doing data sharing, for spending the time and the effort here. We can get large samples. We can look at diverse samples. So rather than 14 individuals, we were looking at people between, I don't know, let's say 4 years of age and 97. And so we could show individual differences, age-related trends, both between and within individuals. And, frankly, that entire enterprise would simply not have been feasible or possible if we had to start from scratch here. So, this, I think, exemplifies why we want to share data and make it open. And, as noted, there have been many, many successful examples of this, I think, from NSRR data showing that one can have robust results from archival data. But one should always remember there are, risks potentially, right, in practice that go along with these opportunities. Perhaps obviously, these studies weren't designed for this particular purpose, and so they're convenience studies, they're repurposed in some ways. So, they may have suboptimal measures, they may have various flavors of ascertainment or be unrepresentative and so on. And particularly if they're large, that may lead to spurious effects of these subtle biases and so on. So obviously it depends upon context, but this is where kind of careful analysis and replication and just generally good statistical practice comes in. For our purposes here, there's perhaps one other issue, which is clearly it's less work than collecting 15,000 studies from scratch for one particular analysis, but it still can be, a burden, right? And working with essentially other people's data, meaning that there may be unfamiliar conventions or caveats which perhaps aren't obvious. They can be hard to deal with, especially or even in well-documented data sets, but especially in very large, heterogeneous, multi-cohort, multi-site kinds of data sets where one has to take automated approaches to analysis. And as well as increasing the burden of work, this obviously is an issue if any additional extra chance for error, well, by definition, it just increases the chance of ultimately having misinterpretation or error creeping into one's work. And certainly, as you might expect, looking across NSRR data sets, there are a lot of potential ways that one could trip up. These are studies that were collected over decades in different sites by different people. And so, of course, there's at core, I think, a very high quality, but still a very heterogeneous and kind of technical and data standard senses, sets of studies in many ways, even given that they're all just PSGs. So as one, maybe trivial example, if we just look at the number of distinct channel labels in the PSGs, and just considering 6 of the original or earlier NSRR studies, we have 328 distinct labels, although when one looks at these, many of these are redundant and interchangeable terms. So, for example, 6 different labels for abdominal effort channels, and so on, so forth. So obviously, these are trivial examples, and looking at any one of these, looking at any one recording, it's not rocket science to figure out what's what. But in the case of an automated analysis over thousands, these are the kinds of things that need to be dealt with, I think, in a kind of a cleaner manner. As another example, so we can have the context of really the same conceptually information, the same underlying data, but packaged differently in an EDF. So for example, we may just have 2 central EEGs, and we're interested in having a mastoid, contralateral mastoid reference. We may have one study where it comes as 4 separate channels, all referenced to a common recording reference. In another study, it may have already been re-referenced, and it may differ in units, in other properties, and so on. On the other side, we may have the same labels, but actually kind of not completely interchangeable or somewhat conceptually different measurements. And this can happen even within the same study or between different studies. So for example, airflow, in many cases here, it could represent a thermistor or a nasal cannula measuring things that aren't necessarily interchangeable. And kind of beyond these perhaps superficial issues, of course, in studies done looking at many thousands of hours of sleep, often in home-based recordings, there are inevitable technical issues that will arise. And as one just looks at some of the different data sets here in NSRR, you will find many of these kinds of things. And so, for example, looking at the hardware filtering, the spectral slope work, we uncovered some unanticipated prior hardware filtering that had happened to the EEG signals, but that only impacted some physical devices, some recording units, and only some channels. And that led in some cases to some, quite a degree of bias in those studies. It was something that was discoverable by careful analysis, but perhaps not immediately obvious. In other examples, some studies have very strong line noise and subharmonics that extend into the kind of physiological range, if you like, of the sleep EEG. Another example, there are studies where the EEGs are essentially flipped, they're upside down. And in many cases, that doesn't matter. Depending upon the analysis you're doing, that might matter a lot. And so figuring that out is, yet another thing. One other example, heart rate signals could be flat or corrupted in one particular study. And so I don't want to give the impression that there's an endless list of these things, but, as you might expect, in large data sets such as this, you'll come across, and we come across these kinds of things. And even in the best case, of course, in EEG sleep recording, you're always going to have movement, cardiac, sweat pulse, other kinds of artifacts and so on that can be dealt with in various ways or detected in various ways. And that obviously is true. My focus is EEG, but that's obviously true for other kinds of signals, say respiratory signals. And likewise for annotations, same kind of story. Okay, so these are events or staging information. 97 distinct terms, but of course, not all of these are actually conceptually distinct. So just different labels and so on. So these can be collated and merged or harmonized or standardized. I forget the distinction that Ying made. but in any case, one needs to deal with it in some way. And another issue, a practical issue, is with the annotation data that comes along and that we currently distribute with NSRR studies, is a lack of a standardized format for annotation data. So sharing of signal data has benefited greatly, I think, from just EDF, a file format and a standard, a loose standard, for sharing signal data. There's no widely adopted standard for event-style data that I'm aware of. In principle, EDF Plus supports this. In practice, I feel it's limited and awkward to work with. And so this just shows some examples of XML for the Cleveland Family Study, other studies that are using kind of different formats. But again, it can often be trivial to put these together, but it's an additional set of tasks that any user will have to do if they want to do a multi-cohort study, and it always opens the opportunity for error in those contexts. And so reviewing these kinds of issues, the question we asked is, what to do? And so this really, I just want to give a high-level overview of our current and ongoing NSRR harmonization effort to try and address some of these issues. So perhaps obviously, although in practice, it's actually not always straightforward and obvious to do this, but we want to try to fix things that are superficially inconsistent in these signal data. So trivially differences, say in channel labels or microvolts versus volts and so on. Again, the idea here is to make automated processing easier and more robust. But none of these changes would change the underlying data. So these things we fix. For annotations, we want to just define a single format that can be consistent across the different studies and that's both simple and flexible enough for the kinds of data we have. But otherwise, the principle we have here is just to flag and not try to fix, even if in principle we might be able to almost kind of fix some of these issues. We leave the signal data as is in the primary case. So the principle here is that harmonization should not change the fundamental information and the fundamental data. It just should make it easier to work with on a practical level. In many cases, there may not be an unambiguous fix for some of these issues, or indeed, it may make things even worse if you try and fix it, depending upon what one wants to do with these data. Depending upon the analysis, for example, it might not matter at all that the EG is flipped. For other analyses, it might matter. And so these are things that one has to take on a kind of a case-by-case basis. But what we want to do is to build and then also share automated tools to do this so that we can apply it to our own NSRR data, to new studies coming into the NSRR moving forwards in at least a semi-automated manner, and also make these available to others so that different data sets can be harmonized to these standards. I won't go through these in detail, but this is just to illustrate some of the things that we've considered doing in an automated manner. And these are things that we will do to the so-called harmonized EDFs. As you'll see, these are a set of EDFs that we are proposing to post alongside the original EDFs as the default that will be easier to work with because many of these superficial differences have been fixed. Internally, we do some things, and so we make some other changes, for example, filtering, flipping polarity as best we can in order that we do some analyses for staging, spindle, non-rem, transient analysis, and so on. But our feeling is it doesn't make sense for this as a kind of a general case. It may or it may not suit many or most or all users to do that, and so we'll leave these things as is. But what we will do is flag issues that seem clear gross issues in the EDFs that we distribute. So these don't have to be rediscovered from scratch every time, but at least people are made aware of them and can choose to deal with them as is appropriate in their own analysis, which may include just putting those studies aside. So just to try and give an example, just at the trivial level of the labels we use, actually, it turns out not to be quite so trivial when you try and do this in a semi or automated manner. We've basically set up a workflow whereby one can define rules to define a set of so-called canonical signals that are kind of sequentially attempted for each given EDF. And decisions are made based upon the labels and sets of predefined aliases that we generate But then the type of unit, transducer field information, the sample rate, the physical min and max of the signal and so on, the presence of any reference channels. And for each signal, there's some kind of implicit flowchart where we try and do something sensible to come up with a final result that can be easily kind of, that is harmonized between studies. So this is one example for the leg EMG. And so then there's tools to do this, to apply this automatically in our context and for others that we built into Luna. So we're currently still in the process of building a generic NSRR-wide rule set, as I said, that would try to work well for all studies, but also be the basis for the kind of the N+1th study that we get in, and it will help there. So just this is one kind of concrete example, just harking back to the earlier EEG example. In this case, it would take these two studies and it would realize, oh, these are EEGs, these are central, and depending upon how we set it up, if it knows we want to have things that are referenced to contralateral mastoids, it would do that. It changes the channel label, it changes the units to make them standard, but otherwise leaves things as they are. And so we have a harmonized, easy set of kind of channels and names. Also, we choose the names such that they're easier to work with if one is working with these in a kind of an automated context downstream. So we try and avoid spaces and numeric operators and so on. But then this is what the clean data would look like. I won't go into the details of this. We can post the slides and it's documented online. But in the new annotation format, we've tried to strike a balance between something that is, very simple, tab delimited, you can read it into R or Excel and so on and so forth. You can create it easily, perhaps unlike XMLs or EDF plus annotations, yet it supports some of the nuances that are important for the type of data we work with. So different ways of encoding times or durations, the ability to have arbitrary channel and metadata associated with events, and importantly, actual tools then to take in different inputs and output one or more files merged into this particular format. And so we've built a lot of this into the so-called NSRR automated pipeline, or NAP. So this is built on top of, largely on top of Luna. So tools for sleep EEG that we built in my lab. It's fundamentally a command line Linux kind of workflow that we're happy to share. And this is what we run internally. So it's, again, designed to just scale to hundreds of thousands of studies in an easy way. We're also building some kind of interfaces so that external people can work with these same pipelines more easily. And do contact us if you're interested in being early adopters for some of these things. We're working on a cloud-based kind of web-based interface. Essentially, you can just upload an EDF or link it from your Dropbox. It will do all of this processing and give you back a harmonized EDF, plus doing some of the 101 analyses, for example, sleep staging, various other kinds of analyses. And then there's a web-based viewer where one can look at the outputs of this pipeline we've called Moonlight. So as one example, I fed one channel, one study, and I don't know if you can see this clearly, I apologize, but it's mapping the original channels into a harmonized set of labels. And so these will be consistent across all studies. In some cases, it's doing re-referencing as needed in order to get linked mastoid or contralateral mastoid channels. Importantly, whatever's chosen here will be the same across different studies. Likewise, it's taking a set of annotation terms and doing a mapping to a kind of a common set. Again, the idea is they will be easier to work with. There's some kind of bells and whistles we put on top of this to view and kind of work interactively with the raw data now that we have it in this format, either looking at raw signals or summary statistics of, say, whole night recordings. And again, kind of trying to add some value to these recordings, some workflows where we predict stage, or in the context of the NSRR, where we already have stages kind of manually scored in many ways, to evaluate the consistency of those manual staging with the signal data and so on that can be useful. And when we have data in a harmonized, consistent format, it's just much easier for us then to do other kinds of more interesting analyses downstream, things we're actually interested in. So one example here of some spectral analysis of the EEG. And so the goal is, the idea is for others, it would be similarly easier. So the plan is to post the so-called harmonized EDFs and for new annotations and issue triplets on the NSRR as the default download. So this may drop some so-called exotic or undocumented signals from given studies, but what we'd like to guarantee is that anything that is present will follow a standard, understandable, documented set of conventions. We will keep all original raw data available via the NSRR, which I think is always a good idea. But newly ingested cohorts will be mapped to this standard, hopefully with minimal pain if the automated pipeline is working as expected. We expect that over time, we will have to augment and adjust these standards, in which case we'll repost versioned releases of the studies that we've previously harmonized. And as I said, flags files that indicate the kind of known issues on a study-by-study basis in a way that we don't currently do. For people who are thinking of depositing signal data into the NSRR, obviously we're kind of outlining, this is our view of how an EDF, a set of studies should look. It's actually not so important that depositors try to conform to that convention per se. It's more important, I think, just that the signals come as EDF or EDF plus with headers as fully specified as possible with descriptive labels and so on, so that our pipeline is able to do the best job it can. And annotations ideally in a separate machine readable plain text, but pretty much any format, because if it is in this kind of format, it's then easy to convert to our standard. What is more important is just as much documentation as possible describing what's expected, the typical properties of the signals and of the study design and so on, if not otherwise obvious from EDF headers. And that any data we have ideally is the kind of rawest and least redundant form, i.e. not filtered, not transformed, and so on, because it's always harder to go back. We're at NSR always happy to advise and assist if we can for potential upload, and so please contact us. So I will end there. Any questions now, I guess, here, or Mike can lead the more general discussion if we go into that. So thank you.
Yeah, so we had some questions for you, Shaun, but you answered them in your own presentation. Perfect. So obviously very, very informative and good. Okay. Let's just open it up in general. Are there any questions for any of the presenters at this point? We have one raised hand. You want to type the question into the box? Who has one?
I'm happy to have Larry ask this question.
Okay, there. That's great.
Okay, thanks, Shaun. So I was curious about how you standardize the terminology, because that's kind of like the most important thing. But I imagine it must have been really difficult to develop the algorithms to anticipate all the different terms that people use to categorize their data. And maybe that's kind of an evolving algorithm to kind of adapt it to what you see when people send data in. Is it going to happen? Is it going to like being a living algorithm and then kind of be improved over time as more variables come in?
Exactly. I mean, I don't really see, well, I think perhaps there's two answers. So, yes, that is what we've been doing. The starting point has been, a large collection of studies in the NSRR. And what's nice is increasingly more recently, we've had many of the original studies. Dr. Redline, through her amazing efforts over the years, has been central to kind of creating and collecting those data. And so in a sense, they were somewhat more standardized. It's nice getting new data sets in coming from completely different sources, and so we can kind of look at that and learn from it and so on. I think obviously, it's trying to predict every eventuality is going to be impossible. And so we're trying to structure it so that at least it makes clear what it's done, right? And what it wasn't able to do, and so on. And so that one can review and see which channels were mapped, which weren't, et cetera, et cetera. And so we'd like moving forwards as new studies are deposited to learn from that. It was one motivation really for having the online upload tool is that if people were to submit, heterogeneous, differently labeled studies, we can certainly just see that and learn from that. And one example would be perhaps it's the national sleep research resource, but perhaps for some studies that aren't annotated in English and so on, and from different countries, or indeed from here, but just in different languages, and that would be great to kind of to work with. I think secondarily, we have been interested in beginning to reach out to perhaps societies that can help some of the efforts to create standardization and kind of agreed upon terms. We don't necessarily have any particular desire to be the body that does that, nor do we think we should. The starting point is just trying to make sense of our own data. And so I think it's through, frankly, things such as this outreach webinar, and as I said, working with other societies that, as a field, ideally, we could agree upon lists of preferred terms, any nuances we want to avoid, and so on. And so, people who are interested or indeed have done some of this work already, and would love, would be happy to share it. We would very much love to learn from that, and where it makes sense to incorporate it. So it's sorry, I'm not sure who asked the question, but I hope that kind of answers some of at least our kind of logic. I don't know, Susan, others I know will also can also address this.
So that addresses the terminology, but you said, what about the data? You want to take a relatively light touch on the data, and you don't want to over-analyze that or over-standardize that. But are there data that you get looking across databases that just can't be compared? And do you have like kind of a flag for that for investigators who are going to try and do that? For example, you're looking mostly at EEG, but like the study where Ying looked at, where there were it was either the sleep across the night, and sometimes it didn't, or sometimes it did include people waking up. So it's fundamentally a different question, and those two databases, those two streams of data, can't really be compared.
Yeah, sure.
With a reliable conclusion. So
yeah, so no, I completely understand, and my feeling is, what we want to at least take off the table are these kind of trivial, superficial differences that just are a burden and can cause work. Of course, that doesn't mean that. So perhaps harmonization is we perhaps should think about a different word for this, because of course it doesn't mean necessarily that qualitatively different cohorts with different populations, different study designs, and so on. Of course, they cannot be just magically blindly combined. One then has to kind of to kind of look and that's the work, right, of doing the science. And we can't necessarily specify that in every way. I think what we're trying to do is at least remove some of those avoidable barriers up front. So I know that's I think I'm agreeing with you in that I think we're somewhat clear on our goal here. And so it will, of course, depend upon the question one wants to ask, is whether or not one is able to combine things. But we at least want to do what we can to let somebody make that decision themselves as easily as possible.
Thanks. We sincerely appreciate your effort, and your talk really made me realize the enormity of the challenge you're facing.
Thank you.
Yeah, thank you.
We have some more questions. Which other standards are you aligning with, for example, of standards on non-sleep EEG?
Yeah, so we've looked into this a little bit. So yeah, BIDS is something that came up. So frankly, it's something we definitely are thinking about. I'm aware of BIDS, and I think it makes a lot of sense when you have complicated study designs and repeated measures and different conditions, and you really need to make sense of that and look after that. As far as I'm, people can convince me otherwise, but for our context, where we tend to have a single PSG, but then we have a very large amount of associated clinical and covariate data, it just doesn't gel well. It's not an ideal kind of marriage. Saying that, none of these things are mutually exclusive, and so if there was the request for this, I don't think we've had requests for this, but if there are requests for this and it would help, we can certainly post things also in BIDS format or following BIDS specification, as well as what we currently do. So yeah, I agree. We're not trying to reinvent the wheel, but we are trying to do something that I think makes sense for PSG data, and that may or may not come from other standards. I see a question as well about animal models, and I think that's a great point as well. So, currently a lot of NSRR data, it's human studies in a particular context, right, of often single night PSG. And so you can imagine other kinds of designs where you have, say, intensively longitudinal data. At the extreme, you'd have from, say, circadian studies, kind of many repeated measures of EEGs, perhaps including wake data. I think we would need to change our structures somewhat, in order to kind of make a good job of that. And animal data too, it's something we thought about. I have collaborators, and we've used a lot of the same underlying analytics to process, in my case, mouse EEG data. Currently, that's not part of NSRR. Obviously, it would require some adjustment to, many of the kind of features if we were to include that. And so it's something that we're not currently doing, but we are actively thinking about. We obviously want to make best use of our time and our finite time and energy. And so, it's something I think as more people come to us, or as we solicit people with relevant animal model data that they want to share, that is the carrot for us to, then building up some of the, the kind of resources and so on that make that easier to work with. But it's certainly something we'd love to have. Susan, and I know Mike, others that you've thought about non-human data and other types of study design, including high density EEG, or even other kinds of sleep-based studies.